Hello students, welcome back again. You know that this video series on computer system architecture, that is paper number 2 of BSc Computer Science CBCS first semester, and we are discussing combinational circuit. So in the last video we have discussed the two most important combinational circuits, that is multiplexer and demultiplexer, and today we will study another very important combinational circuit, that is decoder. So let's begin. So what is decoder? Why they are used in computer science? So all this will be discussed in today's video. So what is decoder, or why they are used? So decoders are used whenever an output or a group of outputs is to be activated only on the occurrence of a specific combination of input levels. So these input levels are often provided by the output of register. So when the decoder inputs come from a counter or register that is being continuously pulsed, so that decoder outputs will be activated sequentially. And decoders are widely used in case of memory system of computers also. Also, decoding of data is needed by many digital systems. Applications such as data multiplexing must have decoding. Decoding is necessary in such applications as data multiplexing, rate multiplying, digital display, digital to analog converters, and memory addressing. It is accomplished by matrix systems that can be constructed from such devices as magnetic cores, diodes, resistors, transistors, and FETs. So what is decoder actually? So decoder is a combinational circuit. Decoder is a combinational circuit that has n input lines, that has n small number of n input lines and maximum of 2 to the power n output lines. Okay, n input lines and 2 to the power n output lines. One of these output lines will be active at a time. Okay, though there is 2 to the power n output lines, only one output line will be active. This active output line can be said as high based on the combination of inputs presence when the decoder is enabled. That means decoder detects a particular code. The outputs of the decoder are nothing but the min terms of n input variables or lines when it is enabled. If the n bit decoded information has unused, the decoder output will have fewer than 2 to the power n output lines. We will see the next in the function table. Okay, so a decoder, you have already got the demultiplexer combinational circuit. A decoder is some extent similar to the demultiplexer. Decoder is up to some extent similar to a demultiplexer, with one expectation: there is no data input. A single binary word n digits in length can represent to the power n different information. For example, we will see the 3 line to 8 line decoder. 3 line to 8 line decoder. It is also called binary to octal decoder. So in this case, 3 inputs are decoded into 8 outputs. 3 inputs are decoded into 8 outputs. So here inputs will be 3 and outputs will be 2 to the power 3. That means 8 outputs. So each output represents one of the min terms of 3 input variables. 3-bit binary decoder whose control equations are implemented in this figure. In figure 4.26, and the operation of this circuit is listed in this truth table. You can see the truth table. So these 3 are the inputs and these 8 are the output. Only one output is active at a time. You can see here only one is in the first row. That is, in the first case, D0 output is activated. When inputs are 0, 0, 0, then D0 is activated. D0 output is activated. When input is 0, 0, 1, D1 is activated. That means D1 is 1. When 0, 1, 0, then D2 is activated. When 0, 1, 1, this D3 is activated. That means D3 is 1. Similarly, you can see only one output is activated at a time. So when you try to remember this function table or truth table, you just need to remember this, that diagonal elements are 1. Diagonal elements are 1 and the rest are 0. And here you can write the truth table for 3 variables. That means first column is 0, 1, 0, 1, 0, 1, 0, 1. 0, 1, 0, 1. And then 2, 0, 2, 0, 2, 1, 2, 0, 2, 1. 0, 1, 0, 1. 2, 4, 0, 4, 1. মানে মনত ৰাখিলে হ'ল। তো ইয়াতে এটা সময়ত এটা 1 হ'ব। ডাইগোনাল এলিমেণ্টবিলাক 1 1 কে আহি যাব। ঠিক আছে? তো এইটো যদি আমি হেৰি আকো, যদি আমি লজিক ডায়াগ্ৰাম আকো বা সার্কিট আকো, তেতিয়াহ'লে সার্কিটটো কেনেকুৱা হ'ব অলপ সৰু কৰি দিওঁ, ক্লিয়াৰ হৈ যাব। হোৱা নাই। ঠিক আছে, এতিয়া দেখা পাইছা ট্ৰুথ টেবলৰ পৰা আমি এইটো আঁকিব পাৰোঁ। ট্ৰুথ টেবলৰ পৰা D0 আমি কেতিয়া পাইছো, যেতিয়া A dash B dash C dash হয়। যেতিয়া D0 টো আমি কেতিয়া পাম, যেতিয়া A dash B dash C dash হয়। সো আমি A এটা সিগন্যাল লৈছো, B লৈছো, C লৈছো, ইনভার্টার লগাই দিলে A dash হ'ব, ইনভার্টার লগাই দিলে B dash হ'ব, ইনভার্টার লগাই দিলে C dash হ'ব। সো এই ইনভার্টাৰৰ পৰা আমি যদি কানেকশন এটা আনো, এটো আমি কি পাই যাম, A dash B dash C dash পাম, এন্ড গেট লগাই দিলে। ওকে, সো when we get D0 1, when this is A dash B dash C dash, it means when 0 0 0. So if we need A dash, then we have to put an inverter here. So again for B dash we have to put an inverter here, again an inverter for C dash. So here come A dash B dash C dash. So if we put an AND gate here, then the output will be A dash B dash C dash. Similarly for others, if we need complement of a variable, we have to take the line from this inverter. For uncomplemented, just draw the line from here. Okay, যদি ইনভার্টার লাগে, ড্যাশ লাগে, A dash B dash C dash লাগে, এই ইনভার্টার পুরো লাইন বিলাকৰ পৰা আমি নিব লাগিব, আৰু কমপ্লিমেন্ট নথকা বিলাক ডাইৰেক্ট নিলে হ'ল। এনেকৈ আমি লজিক ডায়াগ্ৰামটো আঁকিছো। This is the function table and this is the logic diagram of a decoder. Okay, so in your exam the question may come like that: explain the function of a decoder, or What is decoder? What are its applications? Question comes like that. Okay. So for today, thank you.